Hi everyone, I'm Jodie from Darwin Recruitment. In case you're not aware, Darwin Recruitment are IT specialists across Europe and the US. We specialise in digital and data. My personal focus is within automotive and transport, specifically for the German market. After speaking with a lot of experts in this field, I've actually asked two of them to join us on the webinar to share some of their trends and challenges relating to autonomous driving being quite a hot topic in Germany at the moment. First up, I'd like to introduce Maike, who is a product owner from Elektrobit. Over to you. I think there might be a couple of technical problems.
I cannot hear her as well.
No, we're having a few technical problems, I think. Krishna, would you like to start instead? And then while Maike is fixing her mic. So we'll come back to that. So there's a few technical problems, but yeah, introducing Krishna in that case, who is the head of AI for Continental. Thanks.
Hello. So, hello everyone, Krishna. I'd like to start by sharing my screen. So, can you see my screen now?
Yep.
Okay. So, yeah, so I'm Krishna. Muralikrishna Sridhar is my full name, short Krishna. So I'm the head of autonomous AI services. I'd like to explain this a little bit more before we jump into the presentation. I'm working at Continental for the last 6 years, and for the last 2 years I'm responsible for a project which is called Autonomous AI Services. It is in the direction of transforming the company, the business, in the direction of autonomous AI for autonomous driving, and in the direction of a service-based business model from a product-based business model. So my particular task is both technical and organizational. Technical in the direction of having autonomous AI for autonomous driving, and organizational in the sense of agile transformation towards having a service-based business model. And this is the meaning of the term autonomous AI services. I would like to explain in the next slides what exactly this means. So the future of AI and autonomous driving. This is the first slide. I believe that that AI has gone through several stages of development. In the beginning, we had, for example, AI in the web search engines, data science AI or data-centric AI, and then there was after sensors became important, either in automobile sensors or other kinds of sensors. For example, in IoT-based applications, Sense AI started gaining ground. Sense AI is another term, for example, for computer vision. Computer vision is a form of Sense AI, and computer vision was quite a hot topic for many years. And this is how we have Sense AI, and then with a lot of data pouring into silos, and a lot of information that was valuable from this data, there came that data-centric AI or data science AI. Meanwhile, knowledge-centric AI has always been practiced in for many decades. By knowledge-centric AI, I mean AI which is based on the knowledge of expert. For example, expert systems is another term for knowledge-centric AI. And these have been different forms of AI. And I believe that the future is for autonomous AI. This is what I would, is the topic of this presentation. So I believe, in summary, I believe that AI has gone through different stages and is going in the direction of autonomous AI. And this is the kind of AI that would be is needed for autonomous driving, not just autonomous driving, but also several other robotics applications, which I will also mention. The second point is that there is also another kind of transformation for mobility and in the direction of autonomous driving. So the current business model is that there are tier 2 companies, businesses that are supplying parts and software, for example, to tier 1, and tier 1 supply them to OEMs, basically car companies like BMW and Audi and so on. And these cars are sold to customers as being privately owned through retailers, of course. And it's an end product. The car is an end product. In fact, the sensors that are being placed on the cars are also end products. Once they are on the cars, that's the end of that's basically, it's a product, not a service. And similarly, the cars are sold to customers, and this is the current business model. I believe in the future this will change, because the nature of autonomous driving is quite different due to many reasons. For example, I think we will see a transition from privately owned cars to fleets, the shared services, shared mobility services. I think mobility providers would be gaining grounds in the future, and I'm sure that many companies, many automotive companies, are preparing for this future. And I believe that when we have mobility providers providing mobility for different cities, then the data that they collect from these cars, so to speak, which have sensors, would be very important in order to improve their services and in order to improve the mobility service. And so therefore, I think that in the future we would have a different arrangement where mobility providers could provide data to other companies, possibly, or businesses that provide AI platforms. So the data is provided by mobility providers to businesses that own AI platforms, and these businesses in turn provide autonomous AI and enable the mobility providers to expand their mobility services, such as autonomous driving, in various cities. I think this I believe is the direction in which several businesses are heading. For example, I mean, NVIDIA is a case in point. NVIDIA provides a AI platform of its own and tries to enable OEMs and tier 1 companies to provide AI for autonomous driving. And of course, there are several other companies that are starting to provide such platform, Apollo, for example. So I think this is the direction in which the industry is moving towards, from product-based business model given at the top here to a service-based business model where data becomes an important aspect of such a service, and the platform becomes a key business model rather than the product itself. So this, I think, is a key transformation that is starting to happen in the industry, but I believe that it'll materialize sooner than we think. So this is the subject matter of this presentation. These two broad changes in first of all in AI, and second in the nature of mobility itself. I would like to start by rewinding 6 years back when I joined Continental. We were doing ADAS, driver assistance systems, advanced driver assistance systems. This was the predominant technology, and what did it look like? So the predominant technology of ADAS, driver assistance systems, 6 years back was primarily based on knowledge-centric AI. I'd like to explain the term a little further. Knowledge-centric AI is another word for expert systems. And these expert systems or knowledge-centric AI were regarded as sufficient for the ADAS functionalities for some time. So here we have the three key processing stages in the entire ADAS processing chain. In the first stage, the sensor information is modeled and processed using expert systems, and then based on this sensor knowledge from the sensors, then an environmental model is created. This environmental model is a model of the environment and contains the various objects in the environment, like the cars, the lanes, the signs, and so on. And this knowledge of the environment makes it possible for the car to plan and to control. The typical driver assistant functionalities were emergency braking and adaptive cruise control and lane keeping assist and so on. And these functionalities were mainly intended to make the driver more comfortable, driving the car more comfortable and more safe as well, for a privately owned driven car, right? So this was the kind of a business model. These driver assistance systems were provided along with the sensors and placed in these cars, and with the intention to enable the driver to drive more easily and more safely. But the whole business model was a product-based business model centered upon making the life of the driver easier and safer. So this was the philosophy of advanced driver assistance systems or driver assistance systems for quite some time. And for these systems, it was for many of these situations were mostly in the highways, not in urban scenarios. And for these situations and for these functionalities, for a long time it was understood that that knowledge or expert systems can actually work quite well. But this started changing in the last 6-7 years. So this is where this is what I would be talking about next. What happened was the first big challenge to the legitimacy of knowledge-centric AI was this experiment by NVIDIA, where a few years back they showed how an end-to-end system which maps from sensors, which sense the outside environment, to actuators, which actually have the control of the car. A single neural network could actually do this mapping from sensors to actuators, basically from what the car sees to what the car does. And more so, it was shown that by just training this neural network with data, it was shown that such a system can actually drive under limited circumstances. And the intention, of course, which was very clear even at that point of time, I think, was not to show that they are going to use this neural network to drive autonomously, but rather the whole outcome was to challenge the legitimacy of knowledge-centric AI, because it was believed that only by coded expert knowledge one could actually perform such a complicated task such as driving. But the legitimacy of such a knowledge-centric AI was challenged I believe, by this one experiment, and it is also a show from NVIDIA's side of their capabilities. And this was interesting because this actually created a sensation at that time, and many of the colleagues, I remember, we started talking about it. We started talking about whether a neural network could actually imitate such a complex task such as driving. So this was the initial challenge to knowledge-centric AI. And then it so happened that in the last 7-8 years, deep learning started gaining grounds in many fields. And one of the first places where the deep learning or data-centric AI replaced knowledge-centric AI was in the sensing part. Not so much in the plan and act, but in the sensing part. So, so what I mean is that the perception of the world, meaning detection of objects, etc., was the knowledge-centric AI was replaced by data-centric AI, which is neural networks. This is the first change that happened, and then in the last years, we are seeing increasingly how sensor fusion itself, which is also previously considered to be possible mainly by traditional methods, knowledge AI methods, is now increasingly being performed by data-centric methods such as neural networks. So this is just a picture which shows how a perception pipeline, which involves more than one sensor, such as a camera raw image and a LiDAR point cloud, could actually be, it could be, basically a neural network would take these two as inputs and produce objects. So even sensor fusion is gradually being undertaken by these data-centric approaches, by neural networks. So this is a trend for the topic of sensor fusion towards which the industry is moving. And now we need to ask ourselves this question, whether, if I were to go back here, what about planning and acting? Can all of these also be replaced by perception AI, data-centric AI? What is the solution in the future? What is the industry moving towards? And for this, I would like to say that this is my point of view, of course, that in order for a vehicle to be truly autonomous, it is important that the entire system, not just perception, but the cognition and planning, all of it needs to be learnable. It needs to be AI-based rather than traditional legacy systems. And this has also been my experience in the last years. So I believe that the world is really complex. And just as we adapt to a complex world, in order for autonomous cars to adapt to a really complex world, the agent, the car needs to learn. The agent itself needs to learn. The full AI stack needs to learn like an agent from the environment. And I believe that this is one of the preconditions for the cars to really drive in complex environments. Right now, we don't have any example of a car that can drive in complex cities like Munich or some Chinese cities, for example. We have, of course, the example from Google Waymo, which can drive autonomously fairly well in Phoenix. But of course, with the help of with HD maps and with LiDARs and so on, many sensors. But I think we are still not reached the point where we can claim, where any company can claim that they can start driving autonomously in complex environments, complex cities, so under complex conditions. So this is still a goal that needs to be reached. And I believe that in order to reach that goal, we cannot make a jump towards that goal, but rather we need to evolve towards that goal. And this evolution can come only when the system is able to learn with more and more experience, where the entire fleet is able to learn with more and more experience. And here the graph shows how a traditional system would tend to flatten out at L3, autonomous driving, and an AI system has the potential to learn and get better with more experience, just as we do as humans. So this is my point of view on this topic. Okay, so if that were the case, then how do we build such a system? So one of the preconditions of for having such a system, I believe, is to have a continuous deployment, such as Tesla's data engine here. So this is Tesla's data engine, where they have the entire system or the fleet in loop. So there's a shadow system that is running alongside the original system, which and in which we have a loop such as this, where there is continuously the system is improving its perception. The system evaluates itself and finds out where it's going wrong, which are the images where it's going wrong, and based on this, based on the performance and also based on judgment from the human users, a relabeling process happens, and the relabeling process results in a new training with the new data, and this is in turn, the system is in turn, the cars are in turn updated, the fleet is in turn updated with this new with the new capabilities based on retraining on this data. So what this does is it gives this is a system in loop. It's an entire fleet in the loop. It gives a potential to be able to, it provides the potential to be able to learn more and more from real life situations and get better at the perception task. But I believe that in order to drive autonomously, it's not enough that the perception is improved continuously. It is equally important that the rest of the stack, which is the cognition and the planning, or the sense, plan, and act, you see, the rest of the system has to be learnable as well, and to be evolvable as well. Why is that? When you look at this situation here, this is a typical complex situation in an urban environment. There are many vehicles, pedestrians crossing the road, and so on. And the situation is complex in the sense that it is not just complex in terms of perception, but the situation is also complex in terms of the behaviors of the vehicle, in terms of the interactions that they are involving in. So, and therefore, planning in the real world can actually be quite complex. I mean, we as humans have probably experienced this ourselves when we go to and when we start driving in a new environment in a different country where the rules are different, the behaviors are different. We have probably experienced that it's not as easy to drive as we drive in our own comfort zones. So because we have still not understood or grasped how to deal with the complexity of these new situations. So for the similar reason, vehicles also need to understand how other users, how other road users behave, how they move, how they behave, how they interact, and how to plan in such a complex environment. So therefore, the conclusion of this of the last few minutes, I believe, is that autonomous AI requires that it's not just that the perception is learnable and evolvable, but in fact the entire stack needs to evolve and needs to learn. And this brings me to explaining or defining what I believe should be autonomous AI. I believe there are two key features that characterize autonomous AI, and it's explained in this particular slide. The first key feature of autonomous AI, as I explained just now, is that it has to be a full stack AI. It's not limited to just perception or sensing. The cognition, anticipation, the acting, planning, and acting, all of them have to be evolvable. In fact, the entire system needs to evolve and learn as a whole. It need not be just one neural network that goes from beginning to end. It can be many, many components and sub-components. And this is just a broad, high-level overview of such an architecture. And all of these components need to be learnable and evolvable. with experience. So this is the first feature of autonomous AI. The second feature of autonomous AI, I believe, is that autonomous AI has to combine the best of knowledge AI and data AI. Let me explain this in the next few words. We saw what is knowledge AI. Knowledge AI is basically the AI that is that's relating to expert systems, where humans understand the world in a particular way, and they start expressing this knowledge in the form of code or some kind of Bayesian models and so on and so forth. So that's knowledge AI. And then data AI is it doesn't encode too much of knowledge of world knowledge into the architecture, but rather it takes some neural networks and then tries to learn about the world using the data. So this is data AI. And autonomous AI, I believe, in order for autonomous driving to really happen, autonomous AI needs to combine the best of knowledge AI and data AI. It has to be hybrid. And this autonomous AI has to not only be manifested in the perception, but also in the cognition and the planning. And my experience in these areas has also shown that autonomous AI, which is knowledge AI plus data AI, and also the full stack AI, is a very promising solution for autonomous driving. This is the first. This is how I would like to define autonomous AI. The second. So before we go further into how this autonomous AI then can influence the business model and can in fact is closer to a different type of business model, I would like to first of all clarify a little bit more about what I mean by this hybrid of knowledge and data AI. This is just a technical example. The details are not so important here. This is just an example of a so-called Kalman filter, which is one of the most popular models used in autonomous driving for tracking objects. But what is important here is to see that we have some equations that express the way the physical world behaves, and here we have some neural networks that model certain kinds of noises and so on. So here is an example of a hybrid system, a hybrid of data AI, which is manifested in the form of these neural networks, and knowledge AI, which is manifested in the form of these equations. And here is a composite system that combines these two types of AI, which is knowledge AI and data AI. And our experience has increasingly shown that this type of AI is the most well-suited AI for autonomous driving, not just knowledge AI, not just data AI, but a combination of knowledge AI and data AI, which I call as autonomous AI. And this is also what has been borne out by my experience. So I would like to now shift gears from technical discussion towards a more and go more on the business side of things. So I would like to say that autonomous AI not only is a different form of AI, but it changes the nature of how AI can be used or will be used in the industry, I believe. So I believe that the nature of autonomous AI is suited more towards a service-based business model rather than a product-based business model. Let me try to elaborate here. Let's assume that we have an autonomous AI stack from a certain company. And then we have autonomous mobility and safety providers here who might, this is an example here of an autonomous car, and here is an example of a last mile delivery service. All of these service mobility providers, they are having access to, typically they would have access to a large amounts of data, right? And, but of course they may, and they might want to use this data by themselves, but there might also be an opportunity for businesses to provide autonomous AI to these mobility providers. So if these mobility providers take a lean business model in the sense that they don't want to provide the technology, but just want to provide the service, then in this case, there could be other businesses which could offer the service of autonomous AI to them, in the sense that these mobility providers provide the data, and the autonomous AI businesses, they provide the autonomous AI solutions to these mobility providers. This could be, in my opinion, a possible business model, one of the many possibilities in the future. But I think what really makes this task quite complex for companies like tier 1 companies and like Continental and other Bosch and so on, to have a USP, right, in terms of autonomous AI, is the knowledge part, not so much the data part, right? So these companies and also the OEMs and the tier 1 companies and many of the new companies as well, for example, Tesla and so on, they've been building up expertise on knowledge AI, right? On how to build up an autonomous stack. And this knowledge is really crucial for autonomous AI. It is not enough to have data and then just to train these autonomous AI systems and provide them to mobility providers. It is very important to fuse the data with knowledge. And therefore, companies that have a kind of a potential to be able to use large amounts of data and process it and to generate AI, but also combine it with knowledge. These companies, I believe, have a huge future in terms of facilitating autonomous mobility and safety in the future. So this is my opinion on this topic, and therefore I believe that that autonomous AI, the nature of autonomous AI, leads to a different kind of a business model, where AI as a software is provided to mobility services who provide the data, and so on and so forth. And this cycle is a service-based business model. It's not a product-based business model. It's a service-based business model because it's a continuous process in which the businesses that provide autonomous AI are continuously enabling mobility providers who provide more and more data to these businesses. So that's the reason why I believe that the nature of autonomous AI is such that it is more software-based, it's more data-centric, and therefore it requires a platform-based approach. And this is the content of my last slide before we go on to questions and discussions. So, so I would like to explain that that autonomous AI cannot. It needs to be embedded in a platform. It cannot be on its own. It needs to be a part of a larger platform. And this platform is what enables the application of autonomous AI to several possible applications. Some of them are mentioned here: autonomous mobility, safety, vehicle networking processes. I would like to focus, though, on autonomous mobility and safety. Here we have assistance, and then we have level 3 to 4 autonomous driving, like shuttles and trucks and passenger cars, mobile robotics applications such as indoor robots, off-highway, like these are agricultural robotics, and then delivery robotics. And there are a vast number of applications that one can always imagine. But how do we have an autonomous AI that can be tailored to these applications quite easily, right? So this is I think this would be one of the biggest challenges in the business, from a business point of view. If you were to have providers of these mobility services or providers of these various services, as mentioned here, then who provides the data to whom, and let's say they provide the data, right? And then who provides the service? How is the service provided to them, and so on? There are many complexities to such a business model, but I believe that the industry would go in this direction, because companies that have autonomous AI capabilities will also be able to tailor and quickly do agile product differentiation and be able to adapt or tailor their services to these different solutions different applications. So, for example, if a factory service, if a factory mobile robot provider would like to provide their services for a particular set of factories, then it might be that if they were to provide the data, and then within a few iterations, an autonomous AI business would be able to quickly tailor the autonomous AI service to that particular set of factories, right? Based on the data, and of course, based on the knowledge, and the combination of knowledge and data. And for such a combination, what is important is a platform that provides the full pipeline, starting from the system, the hardware, middleware, and operating system, to the sensors, to data. I mean data collection, labeling, refinement, and so on and so forth. And then to computing, cloud computing across several hundreds of GPUs, and frameworks that are able to manage the computing to hundreds of GPUs. All of this needs to be in place for knowledge AI to scale with data. So the knowledge AI is coming from the experts, and that knowledge becomes scalable with data using this particular type of platform. And therefore, I believe that in the future, companies would have to start developing platforms if they really need to, if they would want to address the challenges of and the competition of businesses for autonomous mobility solutions. So this brings me to my central point of autonomous AI services. I believe that in the future, autonomous driving would be just one of several autonomous AI services that would enable autonomous mobility across a wide range of industries, as shown here. And in order to be prepared for such a transformation in the business, I believe that companies would be building platforms in order to equip themselves to provide a diverse range of solutions. We have seen several platforms in the last decade. Amazon Web Service is a platform, and then there is also different kinds of cloud platforms, product platforms, and it has been shown that platform-based business models have a lot of potential in relation to product-based business models. And I believe that the direction of autonomous driving, ADAS, mobility would also converge in the direction of platforms and autonomous AI platforms and autonomous AI services. So with this, I would like to conclude, and I would like to invite any questions from audience. Thank you very much.
Thank you very much, Krishna. Yeah, regarding questions, if you do have any questions, please add them below. We'll actually run through those at the end. Once we've got, I guess a few people, if there is any questions, we can do that at the end. For now, I'd like to introduce our second speaker, which is Maike. She's joining us from Elektrobit as a product manager. She's going to give us an overview now that we've got past the technical issues. Thanks.
Thank you. All right. So, my name is Maike Voigt, and I work for Elektrobit, and I've been working in the automotive industry for now more than 14 years. Most of the times I worked for Elektrobit in the area of automotive software development. And I'm now responsible for connected services at Elektrobit as a product manager. I'm also focusing a lot on this aspect when it comes to trends and challenges in e-mobility and autonomous driving. And I also have additional insight because I worked for a German OEM in the past for 2 years, and that brought me an additional perspective to all these trends and challenges in the market. So that's how I want to start with my part here. So this is how cars have been developed in the past. So traditionally, when developing a car, OEMs and their suppliers have a look at the car like this is a hardware product. And in the past 1 and 2 decades, software was introduced into the car, and now the value of software and the amount of software in the car is dramatically increasing. And this is where we're actually involved with most of our products at Elektrobit with automotive software. And what we have seen in the past decade now is that usually the electronic control units, the ECUs, are very limited, or not limited. The development of ECUs is very ECU centered, where you have one ECU with one dedicated function, and one department is developing that ECU. So, for example, if you have a body control ECU, so you have one large department developing this with a specific function of that ECU. And this is now changing, and the main reason for this is that the complexity inside the vehicle with new functions and features, with new ECUs that came into the vehicle, also actors and sensors, for example, for autonomous driving or for first driver assistance functions and features. This has been becoming so complex that now we come into the era of new multifunctional high-performance computers. So that's actually the right side here of this slide. So now we have new architecture in the vehicle, service-oriented architecture in the vehicle. And we can now run several operating systems and many functions on a centralized high-performance computers that have really much more computing power compared to the traditional ECUs. And with that, we also have many more new trends and challenges coming into the market. And autonomous driving, that's one topic that Krishna just presented to you. But we have many more topics around connectivity, around autonomous driving, e-mobility. We have to be compliant to safety and data privacy legislation. The vehicles become part of the IoT world, cybersecurity issues, new digital user experience concepts, and e-mobility, just naming some of the major trends and challenges that we have in the market. There, I would like to say that we really have much more trends and challenges in the market, but these are the ones I will introduce now to you. So as we heard from Krishna, we have higher levels of autonomous driving will be in the market soon. And what they all require is connectivity. Krishna told you that you need data from the vehicle. You have to use that data to adapt, to further develop your autonomous AI in the cloud, and then you send back information to the vehicle. And this has to be done very fast. So you need reliable and good connectivity here to provide higher levels of autonomous driving. So this is one aspect, and I guess you have already learned a lot about that part earlier in this webinar. And I would like to step to another issue that's really currently being discussed a lot in the market. So one thing is safety. So while we are opening up the vehicle now to the internet with connectivity, we have to make sure that safety inside the vehicle is always guaranteed. And safety here meaning the safety of all passengers driving the vehicle or being in the vehicle, and all people around the vehicle that can be hurt by a car, for example. So we have worldwide legislation here that we have to adhere, and to always make sure that we stick to all these laws. We require connectivity, but connectivity also opens up the vehicles And then we require new legislation or new requirements to make the car safe again. Privacy is also another aspect. I think you have read a lot in the news in the past weeks regarding Apple Siri, where data has been evaluated and used in the back, and it's not really clear if Apple was supposed to do that. Also, we had some press releases or news in the past regarding Facebook or other companies using data, and the same is happening in the car right now. So OEMs start collecting data in the vehicle to use data, for example, for autonomous driving, but not only for autonomous driving, but also for other new business models, for other new connected services. And here the market, meaning the industry and the government, they have to make sure that data privacy of all passengers is respected. So we need concepts in the vehicle to make sure that the data privacy is respected, and we also whenever we open up connectivity to data, we need concepts for that. So also integrating the vehicle into your personal IoT environment. So for example, smart home or smart devices, or if you use the car in the smart city or within a smart infrastructure, for example, smart traffic lights or any other upcoming topics that will facilitate driving in the city. Here you also require the connectivity, but you also open up the vehicle and you need privacy and safety and security concepts for that. But the good thing here is with higher levels of autonomous driving, we can also provide new UI concepts, new content in the vehicle. Well, best example is that currently a driver would not be able to watch any movies while driving, but with higher levels of autonomy, the driver will become an additional passenger inside the vehicle and will have access to new content, to new digital connected services. And whenever we speak of opening up the vehicle to the internet regarding connectivity, we have to make sure that we have to prevent cybersecurity attacks, and even if anything is happening, we have to mitigate the impacts of these cybersecurity attacks and need concepts for that as well. And my last topic here is e-mobility. Also regarding security measures, because when we're now charging our electric vehicles, we will have charging stations that also support data exchange, and for this we also need additional security measures. But with this data exchange, we can also enable new services. So, for example, that you have an automatic payment while charging your vehicle without entering any credit card information or using a charging card. And another service that could be possible is that you use that data connection to get your latest software updates for your vehicle, for example, for the autonomous AI. And just run through this quickly because I think we come to the end very soon. So I told you about vehicle development and ECU development in the past. So in the past, we just spoke about embedded software. So everything was being done in the vehicle. But now we're opening up the vehicle with connectivity between vehicle and cloud. And this enables us to either develop onboard components for new connected services and backend services for new connected services. But we can also extend already existing software that is in the vehicle with additional services that are run in the backend, or we can include backend services, for example, like weather or news information, and stream these information into the vehicle, and all this integrated into the OEM's development environment. So just run through this quickly again. I told you about high performance computing. So this enables many more complex functions in the vehicle, but also what high performance computing will also mean is that we have much more complexity now, not in the hardware and the software in the vehicle, but directly in the software. So currently a typical body controller has about 200,000 to 2 million lines of code. And when we speak of a high performance controller, high performance computer, we speak of roughly 20 million lines of codes. And this is a new complexity that we haven't had in the past. And also, I guess, Krishna will also confirm that the complexity of autonomous AI software is increasing dramatically and has to be managed in the future.
Maike, sorry to interrupt.
Yeah.
Just your screen isn't moving past the first slide.
What?
Your screen isn't moving from the first slide.
Yes, it is. It isn't. Oh, sorry.
It's not on ours. I don't know if it's a technical fault or if it's just.
Well, it moved on my screen.
Yeah. Okay. Do you want me to try and share it from my side? See if that helps.
Yeah, that could help. Thank you. Oh, sorry.
Bear with me. Sorry.
Did it move for mine?
It moved on yours.
Okay.
So could you please go to the last slide, to one of the last slides, and I think it's.
Let's see if it's just open.
Yeah.
Oh, it's taking its time. There we go. Okay.
Oh, it now works.
Yeah, it's working now. Yep,
Yeah,
I can see it as well.
I did
Yep,
the
sorry.
same, and I don't know why
Continue.
I have technical problems today. This is actually not my day.
One of those days. I'll let you continue.
Well, to tell you, you didn't miss a lot regarding the images I just showed you. I think that text is still working without the images. And but this is important. So we come from that era of embedded software. We're now extending that to the cloud. We develop onboard components for new connected services or backend services for new connected services, but we can also develop new end-to-end connected services, for example, for software updates over the air or for data analytics. And this all has to be a part of the OEM's development system. And this has been the complexity of software lines of codes. And now we get to the part where I tell you this will change further when we speak of high performance computing and also of ubiquitous connectivity. So, for example, with 5G. So now with high performance computing, as I have told you before, we can now start standardizing the in-vehicle hardware and software environment. So speaking of sensors and actors, they are also used for autonomous driving and for other topics. But we can move all these high performance tasks into the HPCs. And then we connect the car again with the vehicle, but now we are always connected to the internet. And while we have that, we can personalize the onboard app environment with a very simple UI logic. We can add content to the vehicle that the user uses very often, for example, HD video content. And then all the app logic that has been in the vehicle before can be now moved to a certain extent to the scalable cloud backend. And this is also something that Krishna said before. We are now speaking of platforms, and I speak of ecosystems and connected services platforms that are all being connected to each other and provide new business models and new connected services for the user, and also more insight to the OEMs and to other companies in the market. So this all, once again, has to be part of the OEM development process. So basically, what I told you now is that we have a shift in the market from traditional ECU software development to high performance computing with service-oriented vehicle infrastructure, creating the, let's call it the smartphone on wheels. And with connectivity, we can create more connected services. We can provide solutions for upcoming trends, but connectivity also leads to new challenges, especially regarding safety, security, and data privacy. And therefore, we also need concepts to deal with that. And connected services will also develop, and with being always online with new connectivity, for example, with 5G, we will get new business models, and we will also need a change, and we will have a change in the in-vehicle infrastructure as well as the connected services ecosystems and platforms that are currently emerging in the market. So that was my part. I hope that speeding up was good to answer some of your questions, if you have any. And sorry again for the technical problems that I have today.
Thank you, Maike. Yeah, with regards to the slideshow moving, our marketing department will share the slides on the bottom of the
Yes.
webinar so that you can see that. I think we do have a couple of questions coming through. Bear with us a couple of minutes. So can you see the first question, Maike?
Yes, I can see that question, and I can tell you there are several standardization consortia and also groups trying to create answers to your question. So one thing is something that Krishna can also answer regarding autonomous driving, but regarding data exchange, software update over the air, data analytics, we have several measures going on in all the different markets. There are standardization efforts in Europe. There are standardization efforts also in the US. Regarding, for example, cybersecurity, regarding data privacy, we have current legislation with the GDPR in Europe. We see the California Privacy Act that has an effect on the overall US legislation, and also meaning that we have a standardization here with the referring legislation, and the same is happening in Asia as well. So yes, there are several groups trying to standardize this, and I would say that the market is still very dynamic, and still lots of things going on, and we're not there yet. And when it comes to smart city, smart infrastructure, we have a really long way to go, although we already have groups here discussing some kind of standardization. Does that answer your question?
I was just going to ask if Krishna, do you have anything to add to that, or any maybe other points of view?
Yes, from the point of view of standardization with respect to AI and autonomous driving, there's actually, I think there's still a long way to go. But I believe that in the next years we would see more and more of open source platforms for autonomous driving, and this would standardize the kind of interfaces between the component architectures and so on. There would be an increasing standardization of many aspects of the stack itself, of AI and so on. So I think this is more that we will see in the future rather than currently. In the current moment, we do have companies like NVIDIA offering their platforms, and we do have some open source platforms like Apollo and so on. But in the direction of autonomous AI, I think this is something more in the direction of the future. And regards to standardization with respect to safety and so on for AI, there's a lot of discussion that is currently happening in different communities, in different parts of the industry about how can we standardize the process, the AI, autonomous AI, process itself. I mean, this is a very, very important aspect, because the knowledge AI was more engineering centric, and we had some amount of control over the code that we are writing. But when it comes to learning from data, and leaving some of the learning to these neural networks and so on, then the standardization of the process becomes very important, because autonomous AI is a safety problem as well, not just comfort but also safety problem. So we need to make sure that the AI is behaving in a safe way, in a comfortable way, for the driver's journey, or for the passenger's journey. Sorry. So I believe that there's a lot of scope for further development along these areas, in these areas.
Cool, thank you. Yeah, we've got a thumbs up there as well. Cool. Well, thanks to everybody who's joined the webinar this evening, and of course to Maike and Krishna for sharing their views and giving their opinions on the market. Of course, if anybody has anything to add or comment on the video below, please do. We're open, and obviously would push those questions out to Maike and Krishna in the future too. And from Darwin's point of view, we actually are hosting a meetup which is relevant for the mobility space. So for anyone listening today, it might be interesting for you to attend in October, which will take place on the 29th at the Drivery based in Berlin. And that's focused around data science and AI. Thanks everyone for tuning in.
Thank you.
Thank you.
Take care. Bye-bye.
Bye.
Bye-bye.